be the bearer of bad news, but we have a test on Monday. Really, it's not a test. It's an overglorified quiz. It's kind of one of those tweeners between a quiz and a test. Quest. It's called a quest. What's wrong? I know. I'm so mean. I'm the meanest teacher that you have in math your senior year. Truth bomb. But really, it's simplifying radicals and it's finding inverses. Both you've done before. Yeah. Yes. All right, so one little chunk of background information about function notation. So if the name of the function is f of x, or g of x, q of x, anything of x, okay, the inverse is written in this notation. Write down her. Okay. So it's f with a -1 exponent of x. Okay? But we read it as the inverse of x, or the inverse of f. Okay. So a little background information prior to us going forward. Okay. Yeah. So today and tomorrow, what we're going to do is we are going to focus in on finding inverses and all that kind of a thing. Okay? Now, finding inverses, not going to lie to you. Whew. Roll up the sleeves. Go time. Okay? What? You think I'd give you an easy Thursday? Yeah. No. Why not? Because, again, truth bomb. Me. You mean? Yeah, 97.5% of the time. Okay? Step number 1 when finding an inverse is you change the function notation back into just y. Okay? So if you're sitting here and you've got f of x equals 4x plus 2. Okay, so that's my function. We're going to find the inverse of that bad boy. The first thing that I'm going to do is I'm going to change f of x into y. Did I go too fast? No. Are you picking up the sarcasm a little bit? Because I'm smearing it on a little thick. Okay? Then, what I'm going to do is I'm going to flippity-flop my x and my y. Just the letters. Not anything else attached to them, any exponents, anything like that. Just literally change the physical location of the letter x and the letter y. So this y is going to go there. This x is going to go there. Okay? So it becomes x equals 4y plus 2. Change from function notation back into y equals notation. Switch your x and your y. Then, now we're going to solve for y. Well, how would I solve this equation for y? Subtract 2 first. It's going to give me x minus 2 equals 4y. Divide each side by 4. That's going to give me x minus 2 over 4 equals y. Once you have it solved for y, then you're going to switch back into inverse notation. So you're going to take the y part now, and you're going to write it as the inverse of f That's it. Change it out of function notation, switch the x and the y, solve for y, switch it back into function notation. That's it. Okay. So, f of x is 3x to the 5th minus 2. One of these, A, B, C, or D, is the inverse. You find it for me. Exactly. All right, so we're going to, first off, we're going to change f of x to y, right? Then I'm going to flippity-floppity those two. So x goes there. Y goes there. With me so far? Yeah. Add 2. Now, the difference between A and D is what? If you divide first or if you take the root first, right? Mathematically, what do? You divide first. Then we take the cube or the 5th root. Now, if we wanted to get fancy, we'd clear that radical in the basement. Okay? But with inverses, I'm okay with radicals downstairs. It's the only time that I'm okay with it. Okay? So that one ended up being D. Yep. Okay? Good? Questions, comments, concerns, clarifications?
How is it now the exponents first?
Okay. So if we branch off of this one. If I go back here to x plus 2 equals 3 y to the 5th. Right? If I take the 5th root on both sides. Okay. I get here the 5th root of x plus 2 equals the 5th root of 3 times, oops, that's the 3rd root of 3. The 5th root of 3 times y. Okay. Just taking the 5th root right here doesn't just clear the 3. Yeah, it clears the y. Okay? But that 3 then gets the 5th rooted of 3. Okay? Now, if it were like, if let's say it was a square root and it was 9x squared, Yeah, then we could, because then we'd get 3x. Okay? But yeah, but 3 is not a perfect fit. Okay? The composition rule. Love the composition rule. Okay? So if f and g are inverse functions, okay? So if they truly are inverse functions, then f of g of x would equal x, and g of f of x would equal x. Okay? So what that means is you're going to take g of x and you're going to put it in f where x was, any spot where x was. Do the math, and in the end, you should just get x left over. Then you're going to take f of x and you're going to put it in g where x was. You're going to do the math. And then you should get x. If you do that in both cases, they are inverses. If you do it in one case, you haven't proven anything. You've just done some work. You gotta do it in both in order to prove that they are inverses. If it doesn't work in one, then they're not. And then you can move on with your life. But if it does work in the first one, you gotta check it in the second one. If it works in the second one, then they're inverses. If it doesn't, they're not. Okay? Now, I understand that there's lots of wordage on there. Okay? Kicker is that you can't just do one. You gotta do them both. Okay? And let's do it. Let's put it to work. Okay? So it says verify that the functions verify is the same thing as proof. Okay? So I need to use the composition property. So I need to say that f of g of x is equal to x, and I need to say that g of f of x is equal to x. I need to say both of those things, or I need to show both of those things. Okay? So G is going to be red, F is going to be blue. Okay? So what this is saying then is I need to put G of x, which is 1/4 x minus 1/2, into F and get out x. So if I do that, f of x is equal to 4 times x plus 2. Well, I replace x now with 1/4 x minus 1/2. Distribute. 4 times 1/4 is 1, times x is x. 4 times 1/2 is 2, so that's minus 2 plus 2. Minus 2 plus 2, 0. So then we just get x equals x. But that just says, now you got to go to the other one. Good? Okay. So now,
And you might
So now I'm going g of 4x plus 2 equals x. So I put 4x plus 2 anywhere there was an x in g. One-fourth times 4 times x. X. 1/4 times 2. Half. 1/2 minus 1/2 plus x. X equals x. Yep. That is the minimal amount of work that you can show in order to verify that those two are inverses. Okay? You got to show at least that much work. Because you got to show them both in order to prove it. Okay? Using the composition rule, are those two functions inverses? So if I do f of g of x equals, got to be x. Okay? So then that's going to be f of 1/3 x plus 1. And oops, tap the brakes. Come on, it's very better than that. That's got to be x. So then that's got to be 3 times 1/3 x plus 1. Then minus 1. And that's got to equal x. Well, that gets me x off the start. Plus 3 minus 1 is, oops, tap the brakes again. Come on, better than that. OCD. That gets me x plus 2 equals x. Are those the same? Nope. So not inverses. On this next slide, what I'd like you to do is, one, I would like you to find me the inverse. Okay? So find the inverse, and then, using the composition, verify it. Okay? So find me the inverse first, and then using composition, verify. What's that look for? What's up? Under that? All right, so this should be like this. Hold on. White, there. There, yeah. That's what, yeah. It should have just been like that. It wasn't, yeah. There we go. Yeah. Well, it should have been, but yeah, so I changed this problem from verify that these two are to find it and then verify it, yeah.
I got it, Liz.
Does that clear it up a little bit better?
No, not really. I thought I had it, now I don't. And what I'm gonna be honest.
Right?
Yes.
Why not?
Oh.
Or you say no to her Carmex theory?
Yep.
Yeah.
Oh, you listen to that?
Oh yeah.
Alright, sweet.
No, it's on video too.
Glad I'm famous.
Okay, so let's call this one g of x. Okay, so then we've got to show that f of g of x is equal to x, and we also have to show that g of f of x is equal to x. So if I put g into f, that's going to be the cube root of x minus 1. So that's going to be then cube root of x minus 1 cubed plus 1. That's going to be x minus 1 plus 1. That's going to be x, which is equal to x. Yes? Okay? Then I got to go the other way. So then I've got to say that g of f of x, x cubed plus 1. So that's going to be the cube root of x cubed plus 1, then minus 1. X cubed plus 1 minus 1 is just x cubed. Cube root of x cubed is x. So all verified. What? Which equals x. My brain hurts. Luckily, we're done for the day. Couple of things. One, when's these 6 problems due? Tomorrow. Exactly. More importantly, what's Monday? Okay.